Hi, it's Mrs. Pope, and today we're going to be dividing polynomials. Our goal is to use long division, that's coming back, to divide polynomials. So I have a little bit of a flashback, probably from middle school, or even maybe elementary, but long division. So I want to show you a simple one with numbers, and then we'll move into the same concept, but using it for polynomials. So here, back in the day, you would have something like this. Let's divide 948 by 7. So the way you would do it, you would ask yourself, how many times does 7 go into 9? Most of you learned this method. So you say 7 goes into 9 one time. 1 times 7 is 7. Subtract, bring it down. So then we have 9 minus 7 would be 2. Bring down your 4. You'd start all over again. How many times does 7 go into 24? Well, the most it can go in would be 3 times. 3 times 7 is 21. Subtract, bring it down. So 4 minus 1 is 3. We're going to bring down that 8. Do it again. How many times does 7 go into 38? Well, it'd be 5 times. 5 times 7, 7 times 5 is 35. Then you would subtract. We'd be left with 3. You have nothing else to bring down. So maybe back in the day you would write remainder 3 or R3 or something like that. But this is the same concept. So we're going to do this with polynomials, and we're going to really learn what that remainder means and how we can write that as part of the final answer. All right, so let's look at our examples. Example 1, we want to solve x squared plus 3x minus 40 divided by x minus 5. First things first is make sure you get them in the correct place. So this, we have x squared plus 3x minus 40 divided by x minus 5. So you want to take x minus 5 into this polynomial. So the way we do it, we look at the x and then we look at the first term. So you say, we're not going to worry about 5 until we start to multiply back. But we say, how many times does x go into x squared? Or, what do you have to multiply x by to get x squared? Well, of course, there's only one x missing, so you'd have to multiply by x. Or if you want to write the 1, you can write a 1x. Keep your variables lined up, so the x's I want to keep together. If I have x squareds, I keep them together. So see, that's why I kept it over here. So x times x, of course, is x squared. Now we're going to use this. X times 5, minus 5, minus 5x. Remember, subtract, bring it down. Same idea. So x squared minus x squared, those go away. 3 minus negative 5, 8x, because it's minus negative. Let's bring down our negative 40. Start over again. X goes into 8x how many times? 8 times. Positive 8 times. 8 times x, 8x. 8 times the minus 5, minus 40. Subtract. These are going to go away. We're left with 0. We have no remainder. So our final answer is x plus 8. You could also check this. Of course, I love telling ways to check work. If you multiply this times this, you should end up with the exact same answer that you started with. Let's try another example. So example, well, what happened to example 2? This says example 3. Maybe we don't have an example 2. Oh well. Here, let's make this one example 2 then, so we don't get confused in our notes. Example 2, solve x squared minus 8x minus 26 divided by x plus 2. So we have x plus 2 on the outside. This is underneath. Start. How many times does x go into x squared? X times. X times x squared, x squared. X times 2 plus 2, x. Subtract, bring it down. Those go away. Negative 8 minus 2, negative 10x. Bring down the minus 26 and start over again. So x goes into negative 10x, negative 10 times. Negative 10 times x, negative 10x. Negative 10 times 2, negative 20. Subtract. Now be careful. These go away. Negative 20 minus negative 26 is negative 20, or negative 20 plus, negative 26 minus negative 20 is negative 26 plus 20. So we're actually going to end up with negative 6 here. Now, we do have negative 6, and we're not going to write just R6 anymore. I'm going to show you how this can actually be written. So we do have, like I said, back in the day, you'd write remainder negative 6. It's not how we're going to write it anymore. So what we have is our x minus 10, that's correct. And then we have minus 6, that's for here. And then we write it over the x plus 2. And this is how you're going to write all of your remainders. So you're going to write what your remainder is, then you have a division sign divided by here, what's on the outside, the x plus 2. So keep that in mind. This is what your final answer should look like. So I think we have one more example now. Actually, example 3. And we're going to solve. So take a second and write this how you think it should be written. Right. Hopefully you wrote x plus 1 divided by x cubed minus 4x squared plus x minus 2. And if we go ahead and start solving this, we're going to ask how many times is x going to x cubed. Now that means it's going to have to be x squared because I have to multiply this x by 2 more x's to get x cubed. So here we have x squared times x cubed. X squared times 1, 1x squared. Let's subtract and bring it down. Negative 4 minus 1, negative 5x squared. We have to bring down our x and start over again. X goes into negative 5x squared minus 5x times. Minus 5x times x, minus 5x squared. Minus 5x times 1, minus 5x. Subtract, remember that's a 1, so 1x minus negative 5x, that means plus 5x. So 6x, let's bring down our negative 2. X goes into 6x, 6 times. 6 times x, 6x. 6 times 1, 6. Subtract, those go away. Negative 2 minus 6 would be negative 8. So we have a remainder of negative 8. And remember, the way we write it, we would have our original x, our answer up here, x squared minus 5x plus 6, and then minus 8 over x plus 1. Thanks for watching, and remember, you are responsible for your own learning.